Hey guys, welcome back to the channel. And today we're going to do some math problems, so let's get into it. We're going to be doing work with rational exponents, which just means fractional exponents. And we're in 2.6, making me laugh already, 2.6, and we're going to be practicing all the things that we've set up before. So the biggest thing that I want you to recognize here is that the properties of exponents can be used to explain why this is equal to this. Okay, and here are some more examples of using properties of exponents with rational expressions. And for each one, all I want you to do is rewrite the expression using the properties of exponents and explain the expression means in terms of the context that we were talking about with Carlos and Clarita from earlier. Now, they do not want you to evaluate it, right? So if your answer comes out to be like 1.05 to the 1/2, they want you to leave it like that. They don't want you to evaluate it. They don't want you to, meaning plug it into your calculator and give me some decimal approximation. Okay, so I asked you guys to start these already. And so if you don't remember your properties of exponents, I need to do this thing. Hold on a second. Go here. Yeah. So if you don't remember your properties of exponents, this is the way they go. So I'm going to take this thing and kind of like pull you back to 8th grade and then say, do you remember how to do this problem? Okay, now I want you to do it like this. So a problem like this back in 8th grade would look something like this, like x squared times x squared times x squared. So what I want you to do right now is figure out how you would do this back in 8th grade. I want you to take you back to your 8th grade self and then apply it to this right here. So let me go grab my participation sheet because I know it's going to go fast and I'm going to have to try to keep up with all of you. All right, you all ready? So how would you simplify this? What would you write here? What would be the answer for you here? Very good. A lot of people said x to the 6th, Miss Johnson. Can you pull me back into your brain? Where did you get, I see the x, I understand the x. How did you get 6? Yes, ma'am, I shall. Grab that. Go this way. Yeah, that's good. So how did you get x to the 6th? Very good. You just add these exponents. So I'm gonna snip. Where's my little, there it goes. So I'm gonna snip that little comment there because that is one of my rules. Now, when do you add the exponents? When do you add your exponents? When it looks like that, Miss Johnson. Good. What should I be looking for? So here, someone said, Miss Johnson, add the exponents. Oops. That's pretty good. Add the exponents. So 2 plus 2 plus 2 is 6. Everybody okay with that? So you're going to take the same thought that your friend told you here, right? And you're going to go and put it right here. Why, Ms. Johnson? Because even though these problems look very different, they're actually the same. So now can you take a second and do that and tell me what your response would be here? What would your answer be here? While you do that, I'm going to catch up to you all with all of your awesome participation. Oh man, this is good. Let me get this as well. Very good. You guys are remembering your rules. This is helpful. Someone else said it like this. They said if the bases are the same, then you add the exponents. Okay, and this is when you're multiplying. So I'm just going to add a little context here. So when multiplying, very good. So when you're multiplying and the bases are the same, then we add our exponents. Very good. So go ahead and do that. Don't give me the answer quite yet. Give me a couple more seconds for all of your classmates to have enough time to think about it. Very good. Very good. All right. So now give me the answer for this. You told me here, just add my exponents. What do I do with the base though? What do I do with my base? Everyone says, leave it yeah, it stays the same. So here you're saying, so leave my base alone. And then so someone said, make sure my bases are the same. What does that mean, Ms. Johnson? 1.05, 1.05, 1.05, right? All the same. Okay, so you want me to write 1.05? Yes, sir. Or ma'am, whoever. 1.05, good. And then you want me to, oh, what happened to you? What happened to you? Why did my, oh, because I made it bigger? So can I move this up here? That's pretty good. Okay. And then, so when multiplying, we're multiplying. If the base is the same, then exponents are added and keep the same base. Got it. So you're telling me 1/12 plus 1/12 plus 1/12. So I'm just going to stick this here so you guys can all see my math. So then this is equal to 1.05 to the 3/12. Everybody okay with that? To the 3/12. Okay. So remember when you're adding fractions together, when our denominators are the same, we add our numerators. Do not add your denominators, please. And then I'm just going to simplify my fraction just because I can. So 1.05. Anybody know how to simplify this fraction? 3/12. Anybody remember how to do that? Exactly, 1/4. Very good. So this is our answer. I need to make this a little bit neater. I don't like how I wrote it. Hold on. I'm going to make it obvious to you guys by making a really gigantic 1.05 to the 1/4. Is that obvious to you that 1/4 is an exponent? Yeah, I just want to make that clear. Okay, very good. All right. So this is the first property that we talked about. When we multiply, if the bases are the same, then we're going to add our exponents, keeping the base the same. So I'm going to do the same, very similar thing here. I'm going to scooch this guy up a little because he's in my way. So I'm going to do the very same thing here. And I'm going to change what the problem looks like. So for example, this one would look more like this, like x to the, I don't know, third to the fourth, x to the third to the fourth. Okay, what would your rule be here? What would your rule be here? Very good. Very good. Yes. So in case you don't remember, you just need to go back to your definition of exponent. So let me take a little like side on the definition of an exponent in case you guys ever forgot. So your definition of exponents, x to the fifth. I'm taking a little side, like a side explanation. X to the fifth just means x times x times x times x times x. That's why it's x to the fifth. If you did the same thing here, right, this would be x times x times x times x times x times x, which is, wait, hold on, computer. Come on, let's go. Yeah, so if you count, that would be x to the sixth. Does that make sense? That's why our answer is x to the sixth. Let's see, can I grab you and move you over here? I think that's better. Does that make sense? So if you did the same kind of thought here, this would equal x cubed times x cubed times x cubed, right? Which then this brings us back to this rule, which what did you guys get as your answer? What's your answer for this one? Very good. Very, very good. Okay, a lot of people put x to the 12th. Lovely. Okay, so if that makes sense to you, do you see how you can use the definition of exponents to be like, oh, well, to the fourth just means 4 of them. I missed an x here. Let's go. There it goes. So I got x cubed times x cubed times x cubed times x cubed. I have 4 of them. And then this takes me back to this rule, which you just told me to add the exponents, right? So this is x to the 12th. So what did you want me to do? What do I do with my exponents here? Can someone give me a good rule? So, right. Remember, we talked about this being like the power of the power, the power rule. Yeah. Okay. So now I would like you to apply it to this problem over here. Can I squeeze that in there? Yeah. So I want you to apply this here. So if I had to tell you about this, you would say multiply your exponents. And I'd say, okay, good. When would I multiply my exponents? So someone's going to get it confused and they're going to start multiplying their exponents here. So what do you see as the difference between this problem and this problem? What do you see as the difference? Yeah, it's a power to a power. So this is a power of a power. So basically it looks like this: x to the m to the n equals to x to the m times n. Okay, this is a shorthand way of me to explain this, right? This is the shorthand way to explain this. 1 second. Sure something. Okay. So x to the m times n. So did you do this already here? Did you guys all do this already here? All right, what did you get as your answer here? I know, Power Rangers, that's so funny, yeah. Very good. Yeah, so someone says, hey, Miss Johnson, this is what I got. I got 1.05 to the 1/12 times 6, right? Which equals to 6 times, okay, so over here, just off to the side, just so that we're all on the same page. Oops, too much off to the side, Miss Johnson. In case you forgot, when you're multiplying fractions, right? You're multiplying top times top and bottom times bottom, right? So then I get 6/12, which is just 1/2. Okay. 6/12 to the 1/2. Very good. So I'm going to actually write that 1.05 to the 1/2. Okay. So I'm going to pause really quickly because we rewrote it. And now it says, explain what the expression means in terms of the context. Okay. Explain what that expression means in terms of the context. Okay. So number 14 has, do you guys remember what 1.05 is? Yeah, this was the amount of interest that is being earned, right? And for how many months are we doing it? 1, 2, 3. Very good. Now I already cheated and I told you that I said it was months. What here tells you that we're talking about months? What here tells you that we're talking about months? What here tells you that we're talking about months? Very good. This 12th right here, it tells me that I'm dealing with months. Very good. So this is the growth factor for 3 months of interest. Does that make sense? Yes, exactly. Because 12 months exactly equals a year. Perfect. Very, very good. Okay, so lots of people taking me up on my, hey, if the more you talk to me, the more you will understand how to do this. Very good. It should make a difference. The more you interact with this information and you're not just sitting back waiting for Miss Johnson to explain everything, the more you're going to get it. And so the more I answer questions from you all, the more I'm engaging with you and learning more about you. It's the same exact thing in math. Okay. So what about this one? So this inside here, ignore my 6, ignore my 6, ignore my 6, ignore my 6. This in here represents the growth factor for your interest for 1 month. For 1 month. Then when I take it to the 6th, what does that mean? Yeah, that's exactly what it means. It means 6 months. Yes, and someone else said, this is so good. Wait, hold on, I got to clip this because you guys connected it. So then why is this a half right here then? Someone already explained it. Someone already explained it. Why does it turn into a half? Who understands that part? Why did it turn into a half? And then someone said here, because Miss Johnson, 6 months is the same as half a year. Does that make sense? Exactly. Dang, you guys are, man, I tried to come up with questions that are like, haha, will they understand this? Not to trick you. I'm not trying to trick you. I just want to see how much you understand it. That's my whole goal. My whole goal is to figure out how much are you understanding this stuff. Okay. All right. Very good. So why is this one a fourth though? Why is this one a fourth? Why do they consider that one a fourth? Yeah, because 3 months, 1, 2, 3, 3 months, 3 out of the 12 months is equal to a quarter of a year. Have you ever heard your parent, or I don't know if you've ever watched like business or have you heard people talk about the quarters, like first quarter, second quarter, third quarter? This is why, right? Because it's a quarter, not because it's a quarter like 25 cents, but a quarter of the year. Very good. Okay, so we're going to continue. These 3 problems are exactly what we've been talking about. Here we have a negative exponent. Here we have the same problem basically as for problem 14. And then here we have a division. So I'm going to jump, I'm going to do 16. I'm going to skip 17 for now, just because we have we have a little bit press of time. And then here, I want to do this one. So I want you to pause really quick, try this one, and see if you come up with the correct answers. Okay, here you'll have to remember what happens when we divide. Very good. I'm going to pause this really quick. So before I have you pause, I'm going to remind you what a negative exponent means. Anybody remember what a negative exponent actually means? We talked a lot about it. I don't remember, maybe 2 lessons ago. What does a negative exponent actually mean? Yes, very good. It means to divide by that many factors. Very good. So let's say x to the negative second just means I'm no longer multiplying, I'm dividing by x, right? And I'm going to square it because that's how many factors of 2 you wanted me to divide by. Divide meaning this negative. So what number goes on top? What number goes on top? Very good. I got even more people participating. Very, very good. Awesome. Exactly. Yes, a 1 goes on top. Okay, so that's going to help you do this one. And this one down here, does anybody remember how to divide? What happens when you divide? So for example, like x to the 7th divided by x squared. X to the 7th divided by x squared. What did we have to do to our fractions? What did we have to do to our fractions here? Yeah, very good. So if you go back to your definition, this means x times x times x times x times x. times x divided by x times x, right? And this canceled to be x divided by x is just 1. Oh, you cannot see what I am doing. There. I pretend that this is a big one. Do you see my cartoon looking one? Yeah, it doesn't look very one-ish, but that's okay. So just know that this is x times x divided by x times x, which is 1. So what are you left with? Very good. X to the 5th. It's fantastic work. So I want you to take these two thoughts here, make it a tiny bit smaller. Take these thoughts right here and then practice on 16 and 18. Practice on 16 and 18. I'm going to make the problem just a tad bigger, but move this over maybe a little. Yeah. Okay, so you're going to pause. You're going to do these two problems, and then we're going to come back in like 3 minutes. Okay, so now that you're back, right? And I wanted you to do this problem here. How did you do this problem? What did you do? Oh, okay. I'll unlock it. So how do you do this one? What is it? No problem. What does this negative exponent mean? It means to, right, divide by this factor. Very good. So we are going to write 1.05 just on the bottom with the 1/12. Okay. So that's our answer. So in context, this is kind of funny. Okay. So I'm going to bring you back over here to our this thing here. Here we multiplied by 1.05 to the 1/12. When would you divide by 1.05? When would you divide? So remember here we multiplied to get that next month. When would you divide? Remember going backwards? Do you remember who I always reference when I divide and go backwards? Right? Right. So that's actually what it means. This number here, 1 divided by 1.0512. We divide when we're trying to find that previous month's balance. Okay. We divide in order to get that previous month's balance. Does that make sense? Okay. Okay, last one here. So 1.05 squared divided by 1.05 to the 1/2. Here, you guys told me, oh, all you have to do is subtract, right? 7 minus 2 is 5. All I had to do was subtract. Okay, so can I subtract these? And everyone's like, yeah, Miss Johnson, subtract them. Okay, so I go like this, 1.05 to the 2 minus 1/2. What's 2 minus 1/2? What's 2 minus 1/2? Yeah, it's 1.5, right? But we don't ever write it as 1.5. Like, please don't write it like this, because we tend not to use mixed numbers in this level of math, right? So we will write this as an improper fraction, 3/2. Ms. Johnson, can we put it as a decimal? You know what's interesting is I've never really, I don't know, whenever I think about exponents, I think about whole numbers, I think about negative numbers, I think about fractions, but in general, we don't necessarily use decimals. Does that make sense? And there's a reason why for that. And it kind of has to do with what this fractional exponent 1/2 actually means. Okay. So keep your exponents as either fractions or integers, okay? So what is this for, Miss Johnson? Like, what would you use this for? Well, you take it back to the context of 1.5. How much interest is this going to be if the number up here was 1.5? Yeah, 1.5 years, which is 1 year and 6 months. Very good. Very, very good. Okay, so one of the phrases that I want to keep saying to you all over and over again, because it worked in number land or because it worked in exponent land, it's going to work with these fractional exponents, okay? It's going to work. If you remember your rules when the numbers were integers, like, right, these are all integers, exponents, right? Then those rules still apply when we're using exponents. Now, it may look different, like when we multiply fractions, it looks different. When we add fractions, it looks a little different, but the concept is still there. So the phrase that I keep wanting to use is math may not be easy, but it should make sense. Okay.